Thank you. It's a real honor to be here, and really appreciate the opportunity to speak with you all today. I just wanted to thank everyone in the room for your service and the work that everyone here does to support our great country. So when we want to protect things we really care about, like nuclear weapons, for example, one of the things we do is we split them up, spread them out, and move them around continuously on submarines. And my hope is that today, by the end of our talk, that concept and that framing will make sense as a real paradigm shift in how we can think about data security. The theme of the conference here is data as a weapon system, and we've seen some really phenomenal iterations of that and embodiments of that with AI, machine learning, deep learning, using advanced analytics to better understand adversaries and establish more powerful capabilities. And even physical weapon systems are now increasingly powered by data. The challenge is that if data is the weapon system, data also becomes a vulnerability. There's actually a really interesting report out of MITRE pretty recently about how as more physical weapon systems have data components, the concept of blended operations is really a vector that can degrade the capabilities of physical weapon systems by attacking the data components and can do things like sabotage, command and control. And just as an example they gave in this MITRE report was aircraft in many cases can have over 10 million lines of code these days. And the challenge is, if data is a weapon system, what I really want to talk about here today is, what is the battlefield? Is it the same as before? Or are there new battlefields, new infrastructures? And how do those new infrastructures affect the strategies for offensive and defensive capabilities? One thing that we know as the infrastructures are shifting into the cloud, into these distributed and decentralized environments is we can't trust the network as much. The network now is owned by others, third parties, and it's just not trusted. But we have to trust data. And this is a complete paradigm shift from where we were before. A good example in the private sector is Google, where they've implemented Beyond Corp as a strategy to essentially eliminate VPN in the enterprise, because they already assume even their VPN network would be untrusted, and it's all about the data protection and authentication. And then the government sector just saw a really interesting talk yesterday where a gentleman from the NSA was describing how they're starting to rename the VPN part of the tech stack. There's something called multi-access. It's part of this trend. And so if data is distributed and decentralized, there are many infrastructures. And I want to talk about some of them. So what I'd like to touch on today is, what are the challenges with data security today? And what are some of these new infrastructures? And what is this concept of moving target defense? And how can it change how those infrastructures are guarded and also weaponized? I'm not going to pitch CryptoMove, but I will reflect on some of our specific experiences in these areas. So the number one challenge for data security in just the experience we've had talking with many different agencies and Fortune 100 companies is prioritization. Even today, the predominant investment and spend is still on threat detection and network security. That's the priority if you just look at where resources are being put. And it's a really interesting question about why is that the case? And I don't know the answer. One theory might be that the network and threat detection, that's something that the IT and operations can control. Can control the network, lock it down. The data is actually generated by users. And to protect data and change how we approach data requires forming new ways of interacting with users. And there was an interesting comment earlier about how, in some cases, less than 10% of data is even discovered. And in this world, attackers have an asymmetric advantage. Attackers can actually hide in these untrusted networks and evade the detection and plan out and map out their attacks. Meanwhile, the pretty much only game in town for data protection is data at rest encryption. But it poses challenges, especially in distributed and decentralized environments, and requires innovation. There are plenty of examples historically of encryption algorithms getting superseded by faster computers. There's bugs and implementations and vulnerabilities. You see the example of Heartbleed. And inevitably, there's this thought that at some point, quantum computers will be able to unravel things like RSA. There's an interesting quote from the IBM director of research about this issue. He said, anyone that wants to make sure that their data is protected for longer than 10 years should move to alternative forms of encryption now. And it's something that we know the NSA and NIST, they have the call out for new post-quantum algorithms. And there's some really interesting research there being done for things like lattice-based cryptography, and there's a lot of effort there. There's an alternative approach, and this gets into kind of the next topic around moving target defense, which is, what if you could combat the challenge of quantum computers without new encryption algorithms, and instead just made data itself a more difficult target to attack? And the theory goes, if you can't identify the data of interest, how can you launch a cryptographic attack? It's something that the government's working on. We were just in Keystone with the cable industry, with some of the giants like Comcast and Cox, where they actually have a priority around this. So I want to talk about moving target defense, and what is it, how can it affect our thinking around data, and how can we leverage it? It's a really interesting concept. It's actually pioneered in many ways by the agencies and departments in this room. The Air Force has had a moving target defense research initiative in the research labs for a long time. The Department of Homeland Security as well. And has really pioneered this idea of taking the defensive infrastructure and making it dynamic, polymorphic, shifting over time. And it relates to some of the classical strategies of physical warfare. The idea of moving target defense is it can actually flip the threat model. Whereas today we see this curve, the difficulty of attack, as adversaries can hide in networks, study data, it goes down. But if you can make that defensive infrastructure dynamic, you can actually change that game. From a risk theory and a game theory perspective, it's possible to actually make things harder and make time a disadvantage to attackers. And it's a really interesting concept that is taking off, not just in the federal space and the private sector. There's a lot of interesting academic work on moving target defense, and many papers now almost every few months. And we're not the only country working on this. So there's some reports out of China in the last few months around something they call the mimic defense system. It's hard to know what's really true. Probably you guys know a lot more than I do about it. But as reported in Xinhua News, it's a system where it basically self-heals, mimics the attacker's approach. And they did a hacking competition with 500 different vectors and hacking teams from all over the country, including China and internationally, from Ukraine, Russia, Europe, and they couldn't break in. So it's an area of heavy focus. The interesting thing is that all of the research in moving target defense, or most of it to date, has been focused on networks and the application layer, but not data. And that's CryptoMove. So that's really where we're focused on. That's why we're here, is we're taking this moving target defense concept and we're applying it to data protection. All of the data that's powering the new weaponized capabilities can be protected with moving target defense by fragmenting it, splitting it up, spreading it out, moving it around continuously, kind of like the nuclear submarines. And there's a lot of other things we can talk about and check out. I'm happy to share this afterwards, but here's just some of the papers. There's open source tools that can be used to kind of play around with moving target defense and those types of things. So I'm not going to belabor that, but just happy to share later. So if we go from that moving target defense paradigm shift and then start moving towards the infrastructure, how is the data that we're protecting shifting around infrastructure? First thing I want to talk about is the cloud. The cloud really can unlock data as a weapon system, I believe. It could be a major transformation. Just talking to some of our contacts in the federal government, one of the things it can enable is collaboration between agencies and using shared infrastructure. I think we saw it in the panel earlier today, where once you use APIs and things like S3 buckets and Elastic, it can really open up new opportunities. And I think compared to a few years ago, it's probably safe to say that the cloud isn't really viewed as something that's scary anymore. Now the question is, how do we get there? What do we have to do differently, and how do we enable that transformation? The thing about the cloud is, again, you can't trust the network. It's a zero trust model. But on the flip side, you really, really have to trust the data, because that data is informing all of these new capabilities. And in this environment, you can see here, keys can really become the new crown jewels. As you think about APIs and S3 buckets and access and disintermediating these silos, controlling that with encryption keys, with API keys is vital. And there's a massive proliferation of them. Something we've worked on with one of the top 5 banks in their Elastic cluster with CryptoMove. There's some examples here where a lot of the cloud migrations do lead to risks around key mismanagement for API keys, leaving S3 buckets open, and things like that. So the cloud is here, it's coming, we're all excited about it, and it can open up new data, weaponized opportunities, and other things. But is that it? Are we done once we move to the cloud? Will that be the last transformation? I think not. There's a pendulum. If you look in the history of computing, there's a long-term swing back and forth between centralized and decentralized computing. Mainframes and terminals that access them, to more powerful desktops and endpoint devices, now to cloud infrastructure. And what's next? Well, the logic might be that it'll go back towards decentralization. And this is something that is in the very early stages. In the government, it is being worked on, as well as in the technology industry. And I'm talking about decentralized computing, things like blockchain, and kind of moving away from the cloud back into that form. And so we should always think about kind of what that next transformation will look like. And I actually saw yesterday, went over to AWS booth, and they had this Snowball Edge device where they can actually run EC2 and Amazon infrastructure on the edge. And so I thought that was an interesting example of the cloud kind of falling down to earth, almost turning into a fog. And so the question is, how does decentralization affect data, and how can the concepts of moving target defense continue to serve us well in that new world? So you have a bit of a history here. People have been trying to split data up and put it into different places for a long time. There was a Berkeley Ocean Store initiative where it tried to use everyone's computers as one computer. Tahoe LAFS is an open source tool that's pretty slow, but you can use it. One of the most successful commercial tools is called CleverSafe, which had actually got its start in the IC. Ended up getting acquired by IBM and built into their software cloud. And there's other tools like SimForm. And now there's a whole new wave of these decentralized, actually built on blockchain-based decentralized storage technologies, like you see here, MaidSafe, storage, IPFS. And really what they're trying to do is rewrite the entire internet and storage fabric. And if anyone bought into these, what they call initial coin offerings on some of these blockchain companies, I don't know if you follow the price of Ethereum, but my condolences. It's down another 7% today. But these are interesting technologies that I think could really revolutionize the next wave of data protection. And the point here is that it changes, again, the threat model, where the data in this world might actually reside on some random person's computer anywhere in the world and be governed by blockchain. And it also has the same issue with keys, that with these blockchain applications, if you saw the talk from IBM yesterday, every transaction is mediated with a key. So just imagine not being able to access a database if you can't find your key. And that completely changes how many keys there are, how to protect them. And that's where we see a lot of the hacks. So you can kind of see where the trend will go by looking at some of these early applications where there's hundreds of millions of dollars being stolen from Bitcoin and cryptocurrency exchanges by people going after and attacking the keys. And the interesting thing is if you could make them a moving target, it would make it much more difficult. And I don't think this is theoretical. The government, we know some really interesting blockchain projects that are already underway in R&D labs, some interesting applications, and can help both with offensive and defensive capabilities. And definitely in the private sector, we're seeing some of the top 5 banks and pharmaceutical companies leveraging these technologies as well. So that's kind of a cloud infrastructure shift we have to be aware of. The next thing that I would want to talk about is around another infrastructure shift, around the edge. And data, as it becomes more weaponized, actually residing on devices. And we're talking about the Internet of Things and drones. And I want to draw an analogy to smart cities and try to analogize those to base and some of the challenges around data security there. The thing about IoT and data is the opportunity is massive, but there's an exponential increase in the amount of data on these devices. We actually just came back, my colleague and I, from Black Hat from Vegas, and we saw some really interesting hacks of researchers breaking into ICS systems, all the dockless bikes and scooters you might see rolling around places like Santa Monica. I think they have them in DC. They just banned them in San Francisco, interestingly enough. And they have more data on them, and they're really turning into computers. And the challenge here is that there's a blending of the physical and the digital. And so if you analogize this to bases, I was talking with someone from the Navy about how many of the bases, they're adding more sensors, camera capabilities, they're adding connective capabilities to simple things like lights. And that's phenomenal. It can empower new forms of data analytics and capabilities, but it also creates vulnerabilities and now becomes a threat vector. What if you could take over connected devices and use them to mine cryptocurrency for criminal ends, or just shut the lights off, or ground machinery? And I think that there's a really interesting example for how the federal government can drive innovation in an area like this, and it comes from NIST. And so NIST has been working with smart cities, and so all over the world there's these cities like Barcelona, plenty in the United States where they're modernizing, they're adding connectivity. It's been a wave, a massive trend. But like with anything else, security is often bolted on afterwards. And we see a few examples, like with Atlanta, the ransomware attack there. Just recently, there was a town in Alaska where they had to go back to typewriters. And what NIST said was, they said, 2018, this year, we're really going to focus on smart city cybersecurity. And we're going to try to make that a priority and build it in as an initiative for all of these smart city innovation projects. And it's been a phenomenal partnership between the public sector, private industry, and academia, startups, and big tech companies alike. And we're actually part of this. So CryptoMove, we've had an opportunity to work with NIST, with one of the cities in the Bay Area, and have been able to actually use moving target defense technology to protect things like smart lights and sensors. And it's an example where they actually have a lights deployment already out, and the security wasn't really thought about, but now it's being baked in to the capability. And the thought is that you can use those types of engagements and projects to build case studies and reference architecture. And the thing about these types of IoT and edge infrastructures, and especially around government, is you need a long-term innovation focus. It's actually not always that great to be disruptive in this type of environment. It's important to be careful and deliberate and to think about the long term. It's something we've learned working with these cities and municipalities. And so I think that's an interesting model. AWS is involved, the cloud infrastructure organizations are involved, and startups as well as the federal government. Next thing I want to go over related to IoT and edge is drones. And this is something that is close to us, something we know a lot about, based on some of our work around drone security with the Department of Homeland Security and their Silicon Valley Innovation Program. Drone is a really interesting example because it blends data as a weapon system and and also a weapon that's powered by data. That this drone, the small UAS device here, actually has an embedded Linux device. It's running a Yocto Linux operating system. It can do a lot of things. It's probably more powerful than some phones. And the challenge with these devices, just like with everything else, is the security is often baked in afterwards. And so with drones, there's things like spoofing, takeover, physical attack on the drone itself, and then trying to get the data off of it, the disruption of control of these drones, and the navigational protocols, things like NavLink, which is a navigational protocol for drones, out of the box supports encryption, but is found to have some limitations. And there's some interesting research I'm happy to share about that, some in the United States, some actually coming out of NATO. And it's important to also rethink, how do we apply data protection on such a small device that might be in a hostile environment, an untrusted network? We've seen some live demos in the desert where the connectivity drops, comes back, and there's a need for more lighter weight, in this example, encryption algorithms. And again, if we go back to the cloud infrastructure transformation, to the edge, the IoT transformation, to blockchain, decentralized transformation, and here, it's all about the keys, and in a different way. Whereas before we used to have encryption, data at rest, we would store some keys somewhere, put them in hardware. Now, you need a key for every person that might be accessing this drone, almost like keys to a car. And being able to mediate that, manage it, and also protect it. And that's where moving target defense can be an interesting capability. And so one of the things you can do with drones, and this is some of the research that's being done, is take the data on them, split it up, spread it out across the drones. Now if one crashes, falls out of the sky, you can still recover the data on other ones. Even the transmission between the drones is protected. Going back to some of the moving target defense research, there's a phenomenal paper that just came out about how in a one-way communication stream, by using moving target defense, you can actually combat potential attacks on the cryptography and quantum computers. And so I think there's a lot of opportunities for innovation here, and it's following a trend where the data in these new weaponized environments, in the cloud, blockchain, IoT, edge, and drones, we can't just keep using the same technological models and strategies of keeping that data at rest and static. Once the data's out there, once it's in these new infrastructure environments, once it's powering these new capabilities, it should be viewed dynamically and polymorphically, just like everything else. And I think that's a good example of how data as a weapon system requires innovation in how we think about data. So, just some takeaways. I think that data, and this was brought up earlier, is already weaponized. And you see examples of that, we see them all over the place. Whether it's, an airplane with 10 million lines of code, whether it's drones, whether it's cloud infrastructure capabilities that are informing new decision-making with AI and machine learning. And so that has happened. And it's all about how do we wrap our heads around it. But the thing that it changes is the battlefield. Because the battlefield now is not just physical, land, air, sea, or space. Some of the news this week. But it's all of the infrastructure where that data resides. And it's infrastructure that we can't control. It's impossible to control. And so how do we fight back against this? I think there are a few kind of ways to look at it. When we think about innovation, I challenge everyone to think about not just technology innovation, but the vectors of innovation. And what is the source of the innovation? Where is it actually coming from? But also, what is the unit of innovation? What are we actually trying to innovate? Is it new types of data, new types of encryption, or what? I think when it comes to the source of innovation, we're here, we're a early stage Silicon Valley startup, and I think that there are some phenomenal examples of programs in the government, like the Silicon Valley Innovation Program, the DoDIIS, like InQtel, DIUX. The Air Force is doing a ton of work with early stage companies, and new types of vehicles like OTAs to help startups get involved in the government. And the other thing about data is that it requires disciplines and industries to converge. It's a horizontal problem. And so it really requires the big guns, the small startups, the academia, government research labs, all of that to come together. So I guess what I'm saying is I want to plug working with startups as a source of that innovation. The other interesting aspect of innovation is, what is the unit of innovation? Should it just be technology? Should we just get faster widgets and better technology, better machine learning and AI? I think that it will take not just technology to really go and win the new battlefields where data is a weapon system, but actually will take new strategies. And that's the idea around moving target defense, right? It's not just a better version of existing approaches. It's not a longer key length or a stronger algorithm or a better firewall, but it's actually a completely new way of thinking about how to protect defensive infrastructure. It's something you can't do in the physical world. It's hard to move a base around. It's hard to rewire it and change the locations of it. But once you're in that non-physical infrastructure, you can start doing things. And I think moving target defense is a great example. I have to give credit to a lot of the research and development that has been coming out of the labs in this room. It's an innovation and strategy first. It's a rethinking of a fundamental assumption, and then the technology follows. Okay, we have this new idea, this new strategy. How do we apply it to networks? How do we apply it to applications, to data? I think there's going to be other ones. There's going to be lots of those new types of strategies. And so, why does all of this matter? Why should we care about changes in data infrastructure? Why should we care about defending data infrastructure? Why not just weaponize it and just focus on the offensive capabilities? Well, I think that faster access to data, AI, machine learning, those are great things that can enhance capabilities. But the more powerful our weapons get, the more we need to guard them, going back to that nuclear submarine example. And that MITRE report that just came out recently was covered today, actually, in the Washington Post. And it was all about how there's this consideration of changing how procurement is done to look at not just cost, schedule, and performance, but elevating security as a procurement factor. It's part of the deliver uncompromised strategy that MITRE's proposed. It's being looked at. And I think it's a really powerful example of how, as we think about data as a weapon system, we really need to think about how to defend data better. And everybody knows this adage, right? Obviously, you may or may not agree with it, depending on which football team you root for. But this is interesting when you think about data infrastructure. I think that if we want data to be an effective weapon system, perhaps the best way to make that happen is actually a great defense. Thank you.